Flashing across California desert skies, the airplanes you see here are writing new chapters in the story of man-made flight. There she goes.
This is my first opportunity to greet you as Deputy Administrator of the National Aeronautics and Space Administration.
Together, you and I must make our new agency
the most unusual place.
An organization that can challenge conventional wisdom.
We can engineer anything we can write the requirements for.
We're going to make your idea work. This particular idea is quite disruptive.
A typical flight, of course, starts under the wing of the B-52 mothership.
This sleek, high-speed machine would have made Rube Goldberg proud.
The manner in which we fly re-entry from space on the space shuttle was pioneered on the X-15.
X-31 pretty much wrote the book on thrust vectoring, along with its sister program, the F-18 HAR.
An observation of an occultation is one of the more challenging missions that Sophia can do.
Right now, we are looking at the dawn of a new era of aviation.
Most early inventors thought that flight control can be achieved by a pilot simply shifting his weight back and forth. The Wrights, on the other hand, knew that controlling the plane would be the key to successful flight.
Release brakes, throttle to afterburner. Watch exhaust temperature. Watch nozzle position. Check engine pressure ratio now. And all this time, steer down the runway, first nose wheel steer, then rudder. Lift nose wheel at just the proper speed to fly off in the least ground roll.
Today, man copes with a highly complex environment with physical abilities no better than he has ever had.
Greater demands on the air crew call for ever closer relationships between man and machine.
Until now, all flyers have used the force of their muscles, multiplied by gears and motors, to adjust wing and tail surfaces.
Your landing gear and flaps are operated hydraulically.
It's about 45 pounds of force to get that stick to move. It's a very athletic endeavor.
An advanced flight control system called the Digital Fly-by-Wire System has been installed by the Flight Research Center in a modified F-8 jet aircraft.
The pilot of this experimental aircraft need only indicate the desired flight path to a computer, which then calculates and actually executes the control changes needed to stay on course.
The heart of the control system is a digital computer and an inertial measuring unit that were developed for the flight control system of the Apollo lunar module. Use of this kind of control system could make air travel of the future smoother and safer by reducing aircraft vibrations caused by turbulent air through automatic response from the computer to the aircraft controls.
We used an F-111 for integrated engine control.
Further mechanization hopes to make more optimum blending of airframe and propulsion system controls.
A computer-controlled flight system, along with some new control surfaces, allow this modified F-16 to maneuver laterally, change altitude without pointing its nose, and perform other unconventional maneuvers.
The DEEC system is full authority digital electronic control. The fastest calculation loop in the control is 24 milliseconds.
At Dryden, we had been working integrated controls here over a number of years, so we decided to see if we could extend our integrated control approach to let the engines do all of the flight control.
When Gordon Fullerton lands an F-15 and he hasn't touched the control surfaces, all the people who said it was impossible suddenly don't have a lot to say anymore.
This will be invaluable on military and commercial aircraft of the future.
You can bring it in not for just a survivable crash landing, but a precise normal landing, which is what we did, with absolutely no motion of any external flight controls, purely by modulation of the engine thrust.
Using neural networks to identify aircraft stability parameters and to optimize control performance during test flights will reduce development and program costs.
A neural network is a computer program comprised of a series of examples, and in our particular case, these examples are previous flight data.
Power-by-wire actuators only draw power when the aircraft is maneuvering, so that saves a great deal of energy, which in aircraft translates to fuel.
This new software allowed the aircraft's flight control computer to minimize drag by automatically determining the best setting for thrust vectoring nozzles and aerodynamic controls. Thrust vectoring is the ability to direct an aircraft's thrust for directional control, rather than relying on conventional control surfaces alone. The Intelligent Flight Control experiment, to be tested in early 1999, seeks to enable aircraft control systems to adapt to unforeseen changes in aircraft operating conditions.
In addition to advanced controls research, the FAST system allows for simulating system failures.
Data from NASA's Integrated Resilient Aircraft Controls, or IRAC project, will be used to design and develop aviation systems better enabled to safely fly and land damaged aircraft.
One promising technology that may make it possible to improve both aircraft safety and performance is active stabilization of flutter using advanced flight control systems.